So this last problem in section 4 involves the same thing that we were talking about here. We have 2 water tanks in this problem. There's 2 water tanks in this problem, except these 2 are leaking. We're not adding water this time. What's happening to the water? We're taking water away. It's leaking out of the tank. It says one tank contains 10 gallons of water and is leaking at a constant rate of 2 gallons per hour. The other tank contains 6 gallons of water and is leaking at a constant rate of 4 gallons per hour. And then it wants to know when the tanks will have the same amount of water. So, system of equations in this section, just like we did up here, we have 2 water tanks. We need to define a couple of variables here. So what are the 2 things that are changing? Time? In what units? So we're talking about number of hours here. And what about my other variable? Amount of water. And what are the units on that? Gallons of water. 2 variables. X and Y is perfectly fine. Like I've said, some people will choose T for time. Down the road we'll use T for time. But X and Y here is just fine. So now we need to figure out 2 equations. What are the 2 different things that we're talking about that are going to give me my 2 different equations here? What was that? The 2 different tanks. Yeah, we have tank 1 and tank 2. Just like up here, we have tank 1 and tank 2. Some stuff is happening to each of those tanks. That's the giveaway that we're going to have those 2 things for our equations. So for tank 1, we're going to write, I don't want to write equals, I want to put a colon there. We're going to write what? Well, it's an equation, so I got to start off with something. What is it we're talking about here? How much water is in the tank? Yeah. So how much water is in the tank is Y. Y equals how much water is in the tank? Well, I start off with 10 gallons of water in this tank when I start. And then what happens? Yeah, I'm losing water at a rate of 2 gallons per hour. Losing water means I'm taking water away. Take away is another word for subtract. So I'm going to write 10 minus 2 gallons of water per hour. The word per gives away the variable. So that's your first equation. Now we need tank 2. What's it going to be? Y equals the amount of water in tank 2 equals 6 because we started with 6 gallons of water, and minus because we're losing 4 gallons per hour, so 4x there. Now what? Yeah, we want to use substitution on this one. You can use any method you want, but in this case, because we have equations that are already solved for a variable, it's very easy to use substitution. So I can say that since y is 10 minus 2x, I can plug that in right there for that y. And I wind up with 10 minus 2x equals 6 minus 4x. Now what? Solve for x, get all the x's on one side, all the numbers on the other. We can add 4x to both sides, which is nice because that makes a positive x now. We have 10 plus what? 2x equals 6. Now what? Still solving for x, so subtract 10 from both sides and you get negative 4. So we divided by 2 and now we have x equals negative 2. Negative 2 what? We did write down what x is. It's hours. It's negative 2 hours. And right away you notice that doesn't make any sense. Because what does negative 2 hours mean? Yeah, that would be back in time, like before we even started. was when the tanks had the same amount of water. So what's the answer here, technically? Right, we can't have a negative time, so when will these two tanks have the same amount of water? Technically, according to our equations here, never. So never. And it does say explain, so you'll have to say, yeah, or the two lines don't cross, or there isn't a real amount that we get. So it's just some sort of explanation here. Can't have negative time. But in reality, if these two tanks are draining, eventually, what will happen? They both will run out of water, and at that point, won't they both have the same amount of water in them? Yeah. And when does that happen? After 5 hours. So if you think about it, we start this tank with 10 gallons, and we're losing 10 gallons every hour. How long is it going to take for this tank to be empty? 5 hours. On this tank, we start with 6 gallons, and we're losing 4 gallons per hour. How long will it take for this tank to be empty? Like an hour and a half, less than 2 hours, right? So this one's already empty, this one's still draining. But eventually this one will be fully drained, which means that when this one is empty, they both will have the same amount of water in them. So technically in this problem, based on our math, we don't get a solution, but in reality, both tanks will be empty after 5 hours. So they could give you an answer like that if this is a multiple choice test. And then you would have to reason your way down to getting the correct answer of 5 hours. Because in the real world, 5 hours is the right answer. In the world of math, we get negative 2 hours, which doesn't work. All right, so a little bit of extra thought there. It's kind of important that you think as you do these problems.